First day of Chapter 2. We're going to start with this concept that we call derivatives. And before we can really get into anything else, the number one thing that we've got to be able to do is we've got to be able to define what the heck a derivative is. So we've got a few goals here. This particular video is going to talk specifically about what a derivative is, or get to, down here on the bottom, what the definition of the derivative is. So you have this picture. I'm actually going to use a little multimedia here to help me out. So find the slope of the tangent line to f of x at this given point. So this purple graph that you see is f of x. And the blue graph is the tangent line to f of x. Tangent line meaning it's hitting it exactly once. It's kind of bouncing off the line, for lack of a better term. And so how do you find the slope of that line if all we know is point B, which is called the point of tangency? Its coordinates we're going to call generically x and f of x, or x and y. How do we find the slope of that line? So this derivative, its specific purpose is to give us the slope of that line, knowing only point B. How does that happen? Okay, so here's what we try. I'm going to jump to this second picture. What I'm going to do is I'm going to throw a second point, call it D, on this picture. And again, D is on the function f of x, and we'll get its coordinates in a little while. Once we do that, we're going to create this red line. And the red line we're going to call the secant line. Secant, again, a secant to a circle hits a circle more than once. Well, secant to a function, same thing. It's going to hit it more than once. So the blue line is the tangent, and the red line is the secant. Now, how good a job does my red line do estimating the slope of my blue line? Well, not very good. But you know what I bet? I bet we could find the slope of that red line. Well, if I wanted to find the slope of that red line, first off, I'd need the coordinates of point D. Well, generically speaking, we're going to find the coordinates of point D, and then we're going to use that to find the slope of the red line. Well, slope of the red line, we'd need to know what D's coordinates were, and then we'd do the change in y divided by the change in x. So, okay, change in y, you'll notice, would be this vertical distance over here on the side. Change in x would be this horizontal distance down here on the bottom. Well, we need to know what those coordinates are. Well, the coordinates of point D, again, we're working toward finding the slope of my secant line up here on the top. The coordinates of point D, well, let's see. I knew this x coordinate a little while ago, and then I added this change in x to it. So if that's the case, in order to find the coordinates of point D, I'd take x and I'd add change in x to it. If I wanted to find D's y coordinate, I'd take f of x and I'd add change in y to it. All right, so to clear up all this craziness, coordinates of point D. Its x coordinate is the x we started with for point B plus another change in x added to it. The y coordinate would be, well, then let's take whatever this crazy x coordinate is, and let's plug it into our f of x function, hence the f of x plus, or f of the quantity x plus change in x. So if I wanted to find the slope of this red line, change in y, take D's y coordinate and subtract B's y coordinate over change in x, which would be either take D's x coordinate and subtract B's x coordinate, or just use that change in x right there. Now here's kind of the crazy thing. We can look at that and we go, all right, yeah, that's great, but what did that do for us? Well, that found us the slope of the red line. Now how well does the red line approximate the blue line? Not very well. How could we make it more accurate? Think about that for a second. Well, I'm going to go back to this one really quick because it makes it really, really clear. Did I have to put D where I put D? What if I would have put D closer to point B? In fact, what if I put it really close to point B? Because as I'm noticing, as I'm moving point D, the closer I move point D to point B, the more accurate the red line, the slope of the red line will depict the slope of the blue line. So jumping ahead a little bit, we were playing around with all these coordinates. We were playing around with this slope to see what we had. Well, if I want to make the blue line and the red line almost the same, what we want to do is we want to make this change in x right here as small as possible. We still need 2 points in order to find a slope, but if we make that change in x as small as possible, we're in business. How do we do that? Well, in order to find the slope of the tangent line, we're going to take the limit as change in x approaches 0 of the slope of the secant line. So what will that look like? Limit as change in x approaches 0 of this definition of the secant line, or the slope of that secant line up there. And there's some crazy stuff going on here. It looks like gibberish, but what this thing is eventually we're going to find the definition of what a derivative is. It'll allow us, I've only got 1 point. Notice I'm using all x's now. I started with point B. I created a fake or an extra point D, came up with its generic coordinates, and now we're going to use the limit as that change in x between B and D becomes almost nothing. Well, what does all this mean? The slope of this tangent line to f of x is also called the derivative of f of x. The slope of the tangent line to this function at whatever x value I want is also called this derivative. And we've got lots of different ways that we refer to it. Now these first two, that f prime of x and dy dx, you're going to see all the time. Y prime, the third one, I'll use that sometimes, but I'm afraid of y prime because my primes sometimes turn into 1s when I start writing too quickly. And then these other two, the d over dx of f of x, or the derivative of x with respect to y, those are just different notations for this derivative thing. And ultimately, that thing that's in that pink box is what we call the definition of the derivative. What's the definition of the derivative? The derivative finds us the slope of a tangent line to a given function at any point without needing a second point anymore. So that's kind of the big change in calculus that we didn't have necessarily in algebra.